All right, we're on part 2 of solving quadratic equations easily, mentally connecting the graphs with them. And the goal of this entire thing is for us really to be able to look at a quadratic equation. So this is what the first thing on this paper says. Okay, so here's a quadratic equation and be able to jump to the solutions. And I'm telling you, without doing any work at all really on paper, I can just see that the answers to this are going to be 3 plus I root 3 and 3 minus I root 3. So you might also write that a lot of times, obviously, in like your math classes, you write that as 3 plus or minus I root 3. That's two of them. Okay. Alternatively, you could be doing like the quadratic formula. Again, this is just to motivate why. Why is this even a good trick? It's negative b plus or minus a square root of b squared minus 4ac all over 2a. And then you can simplify all that down, which again is not terrible for this. You get square root. This is 36 minus 48 over 2. Let's keep going over here. This whole process, blah, blah, blah. That's negative 12. If you remember, it's a negative because subtracting in there, that's going to give me imaginary roots, which we see. This is 6 plus or minus. We can pull an I out of there because that's what the negative 1 does. And then 12 is the same thing as 2 root 3 over 2. And since I'm dividing 6, and this situation over here, I times 2 times root 3 by this 2, the 2's cancel. And you're left with 6 divided by 2 is 3, plus or minus 2 divided by 2 cancels here. You're left with I root 3. But that's all the work with the quadratic formula. I'm trying to get us to a spot where you can just look at this and be like, oh yeah, it's going to be 3 plus or minus I root 3, without having to do any kind of like crazy mathematical manipulation here. So to that end, let's just review what we did last time. At this point, we should feel comfortable writing out a perfect square. So taking a binomial, x plus something squared, and squaring it out and getting over to here. So x plus 2 squared, it's x squared plus, because this is a 2, the number in the middle is that doubled 4x, plus the number at the end is that squared. 2 squared is 4. Okay? And x minus 5 squared gives me x squared minus 10x plus 25. There we go. Okay. And then we also did last one, we talked about completing the square. And so if we want to make this a perfect square here, and there's a 12 in the middle, so we're looking at this right here, and we want to make that a perfect square, I know that the number in these parentheses has to be a 6. And if that's a 6, this has to be a 36. It's kind of sloppy looking. A 36. Okay. And if the middle number is a 5, all that means is this number over here is going to be half of that, which I'm going to write as 5 halves. And that means this squared is 25 halves. And you could foil, but we're not 25 halves, 25 fourths. Come on now, Mr. Smith. Boom. All right. So that's where we want to be in terms of expanding a squared binomial, and also knowing what the again, the magic in quotations here number is going to be based off this middle number. The middle number tells me this has to be a 6 and this is going to be a 36. It tells me both those pieces of information. So down here, I did an example for you. We had an 8 here, which means that the number at the end had to be a 16, and the number in the parentheses, x plus something squared, had to be a 4 because of the 8. It's always half of that to get to that 4. All right. So when I do x squared plus 6x plus 12, you could think like this. If you felt like it, it's going to be x squared plus 6x. I know the number over here then has to be a 3 because of the 6, which means this has to be a 9. The 12 was already there. And I'm going to add 9 and subtract 9. That's what I just did. The x plus 3 squared is right there. And 12 minus 9 is 3. Okay. Because that's a 4 there, I know that this has to be x minus 2, minus because it's a minus 4. All right, squared. But that means my magic number at the end there should be a 4, but it's not. It's a 5, which is too big by 5. And again, I'm just reasoning out here that if I square this out, I'm going to get minus 4x plus 4. That's from the perfect square, but it was a plus 9. So that means there has to be a plus 5 back here. Okay, and that is exactly what we have. Like right here, boom, this is the same thing as this, which is the same thing as this. They're all the same. Okay. And x squared plus 12x plus 21 tells me that we're going to have a 6 in my perfect square. That's going to be x plus 6 squared. But if I square that out, it's going to give me a 36. I don't have a 36, I have a 21. And that is 15 too little. So it's minus 15 in there. Square it out, you're going to see that works out. And then we also did a couple odd ones. I don't know why I did 3 of these here. It seems like a lot, but I know why I did it, because they're fun to do, you know. Oh man, I got a typo on my thing. I got to change this. So this is not supposed to be an 8 here, but I'm not going to redo this video because it's a lot of work. That's really a 5 sitting there because this is a 5. Okay, and this is the correct answer over here. All right, I had an 8x because I copied this thing up here and I forgot to change it. Okay, anyway. We got x squared plus 5x plus 1. I chose 5 here and here so you could see the example that I worked out. And in the example I'm about to do, the number that I need to be at the end of this is half of that 5, which just like it was up top is 25 fourths. Okay, now I don't have 25 fourths, I have a 1, so there's a plus 1 here, which I know is plus 4 fourths. And since I added 25 fourths, I can subtract 25 fourths. And this is my perfect square. It's going to be x plus 5 halves squared, just like the one above it was, minus 4 minus 25 is negative 21 fourths. Okay, x squared plus 3x plus 4 lets me know that this is going to be x plus 3 halves squared. But if you square that out, you're going to get 9 fourths, right? This is going to become a 9 fourths when you FOIL it all out. And we don't have 9 fourths, we have a 4, which is 16 fourths. So I'd have to add 7 fourths to that 9 fourths to get to 16 fourths. And then all the way down here, very last one, this is going to be x minus 1 half squared, the 1 half coming from the 1 in front of this x. And if you squared that out, you would have got a plus 1 fourth. But I don't have plus 1 fourth, I have minus 4, which is negative 16 fourths, which means I would need to subtract 17 fourths to get there. Okay, so that is our, again, I want to make sure this is like super duper clear. If you FOIL this out, you're going to get minus 1x plus 1 fourth, and I need the minus 17 fourths back here because these combine to give me negative 16 fourths, which is negative 4, which is the term that has to be here. And the x squared minus 1x are just kind of chilling here like that. Okay, so we'd have x squared minus 1x minus 4. Okay. Now, the whole point of maneuvering these things around like this is we're completing the square, and what we're doing is putting this quadratic equation in vertex form. Okay, and it's called vertex form because it lets me know where the vertex of the graph, the parabola, is going to be. And knowing where the vertex is also going to tell us where the zeros are, and that's why we want to do that. Okay, so I'm going to jump around on Desmos, but I'm going to go through these examples that I did here real quick. If you graph just the parent function y equals x squared, right, the most basic parabola that you can get, you're going to see it looks like this. I'm tracing it, I don't know why, but it hits the origin, which is 0, 0, and that's the only root. Okay, so as I move this parabola around, it's going to change where that vertex is, that minimum point down there. That's called the vertex of the parabola. Okay, and knowing how the numbers affect it are going to tell you where the vertex is. So I just graphed a couple for you here. If you graph x minus 4 squared, notice the minus 4 is attached to the x. The whole thing's being squared. So this would also, if you squared it out, be this. But it's a whole lot harder to see the connection to that 4 there, okay? And the reason why I want to see the x minus 4 squared instead of the expanded version of that, which I'm going to erase because we don't care about that, is because it puts the vertex right here. If you graph it, you can see it's right at 4, 0. That's where that is, okay? So that's what this 4 tells me. When I graph x minus 2 squared, which is similar to x minus 4 squared, right? You can see the vertex is right here, and that's at 2, 0, which I labeled down here too, I see, okay? And then the third one I have down here on the left, x plus 3 squared, you can see that moves it. So here's 0, 0 right here. It moves it over to here. So it's actually at negative 3, 0. It moved it left 3. That's what happened. It went to the left, while these ones up here moved to the right. So notice the relationship between this sign, minus, minus. They both move to the right. And when it's a plus, it moves to the left. Okay? And that's happening because all we're doing is moving the 0 of our original parent function, which is right here, 0, 0, okay? But think about this. A lot of times students think putting a minus 4 here should move it left, because when you subtract 4 of something, right, you make it less, all right? But it's actually like the reverse of that, because we're asking the question here, like, what do I square to get 0? What number could I put in here to get 0? And because it's a minus 4, when I plug 4 into this thing, not negative 4, but when I plug positive 4 into here, that's going to give me 0 squared, which is 0. And that's why there's a 0 at 4. So instead of thinking about like the minus 4 moving it, I guess, you're really asking the question, what makes this thing 0? And that's positive 4, because there's a minus 4 in there. Same thing here. Plugging positive 2 in makes this 0, and that's why you see a 0 at 2. Plugging negative 3 into here makes it 0, and that's why you see a 0 at negative 3. Okay? The difference between having a value inside the parentheses is what a lot of math teachers say, and that's what I always say, and a number outside the parentheses, which is like this plus 2 here. Notice the plus 2, or the plus 3, I guess, over here is inside the squared part, right? We're squaring x plus 3, the whole thing. Over here, I'm squaring x, and then I'm adding 2. All right? And because it's outside the squared part, since it happens after the function happens, it affects the y value by just adding 2 to it. So it's kind of like a little bit reverse if you think of it like this. When it's attached to the x inside the parenthesis, a minus number moves it to the right. So it affects it positively, really. It moves it to make the positive number 4, because that's what makes that 0. But when you're adding a number at the end, it just shifts the whole thing up or down. So when I add 2 just to x squared, remember, here's my x squared graph, it just moves it up 2. And you can see that happening here. The vertex was at 0, 0, and now it's going to be at, if you move it up 2, 2, 2. And you can think it just does that right there. Boom, now it's up here. And that's exactly what this graph looks like. And if you subtract a number at the end, outside of the squared piece, it moves it down 6. And I know like the scales are different on these, so this doesn't really get moved down that much. But 5, it's kind of hard to see here. Here's 0. So this is down 5 and 1 more. So that's the negative 6 right there. Okay. So the point is, looking at something like this in vertex form, we should be able to tell where the vertex of this parabola moved to. All right? So when we come over here, when you see x minus 5 squared, that's the whole point of these 3 or 6 questions right here. Tell me where the vertex is. Well, the minus 5 is going to affect it just like the minus 4 did. It's going to move it 5 to the right. Slide to the right. So the vertex is at 5, 0. Okay. And before we jump around too much with these, I just want to hop on the Desmos. I put a link up here in this thing here, but it's just desmos.com. It's worth it to kind of hop on here and play around with it a little bit just to show you what's going on. When we graph, again, 4 squared here like that, you can see it's at 4, 0, right? But as I change this number to like a 5, now it's at 5, 0, 6, 7, 8, right? You can see it. I'm just changing this number. Whatever I'm subtracting is moving it to the right. But if I make it plus a number, like plus 1, now it's at negative 1 is where the vertex is. If I make it plus 4, it's at negative 4. Plus 7, it's at negative 7. Plus 9, it's at negative 9. All right? And what I'm about to do after we do this and look around at this, I'm going to attach to that a number outside the parentheses. And what you're going to see is it just moves it. So the number inside moves it left and right. The number outside moves it up and down. So without that minus 3, negative 9 would make this whole thing 0. And that's why negative 9 is the 0. But once I put a negative 3 in here, outside the parentheses, now when I plug in negative 9, I do get 0 here, but I get 0 minus 3, which moves it down to negative 9, negative 3. All right, so knowing these two numbers here tells me exactly where the vertex is. And what I'm going to show you as we go through here, if I know where the vertex is, I know where these zeros are going to be. And that doesn't tell me, and even if they're imaginary, which is like a nice little trick. And right now, these are kind of crazy decimals, right? Negative 7.268. But we're going to write it in root form later on. But that's getting ahead of the game here. We don't want to worry about that too much. Our goal right now is tell me where the vertex is. So we have x squared plus 4 here. And because it's outside the parentheses, it's going to move it up 4 is how we think about that. So the vertex was at 0, 0. Now it's at 0, 4. This minus 5 moved it to the right 5. The x plus 1 squared, it's inside of it, is going to move it left 1. So we're at negative 1, 0. Okay? And you can graph it. It's going to be right here. Negative 1, 0, which is a parabola opening up like that. Okay? And I really would like students to be able to tie a graph into the equation, because looking at a picture tells you so much more about what's going on. And if you're going to go into further math classes like pre-calculus, like algebra 2 if you're not there yet, calculus, like knowing what a graph looks like is super helpful in a lot of instances, and a lot of questions that seem very difficult to solve algebraically become a whole lot easier to look at if you know how to handle them graphically. All right, so this is going to be plus 8 is going to move it left 8. Minus 2 outside of the x squared, okay, is going to move it down negative 2, down 2. So that graph will look like this, down 2. And that value there is negative 2. And negative 12 is going to move it down 12. So that would look just like this, but it's just down further, just like the one on the right there. It's going to go boom like that, where that value now is negative 12. Okay. And then the rest of this is just me showing you that you can put a number in the parentheses and a number out of the parentheses, and it moves it around. So when I have x minus 2 squared minus 4, I know that the vertex should be at 2 because it's moving it 2 to the right, and that's what this value is right here. That's 2. Okay, you can see the vertex is right there. And then the minus 4 is going to move it down 4, and that's exactly what we see, 2, negative 4. Okay, now, just to talk about this, if this was expanded out, right, this is a lot harder to see. If you expand that out, you're going to get x squared minus 4x. You would get plus 4 minus 4, so you would just get this. So it's not terribly difficult to look at. Hold on, let me make sure all my friends are with me. We would get plus 4 for squaring, and then we had the minus 4 there. So this is really x squared minus 4x. All right, but that doesn't tell me where the vertex is super easily. But once I complete the square and put it in this format, that's super nice. Like this might be nice to tell me where the zeros are, because the zeros are kind of nice numbers. All right, but if you square this one out, you would get x squared plus 6x plus 9 minus 5, which is really plus 4. But the numbers in this, they don't tell me where the vertex is. The 6 and the 4 don't tell me that. There's like formulas you can learn and memorize and all that good stuff, but I'd rather just put it in vertex form. I'm like, oh, it went 3 left, 5 down. It has to be negative 3, negative 5. Okay, and this went 1 left, so 1 left, 2 up, right? Negative 1 and then plus 2 at the end. So that's what that is, negative 1, 2. And this goes 3 to the right and 1 down. So here's 0, 0. If you go 3 to the right and 1 down, that's where the vertex is. Okay. So my whole goal with the rest of this paper here is just, can you tell me where the vertex is? I did the first few. I put them in vertex form. Let's make sure I didn't mess these up at all. I did. This should be positive 1, which I need to change. Okay. So I just typed this up. People make mistakes here. Forgive me. That should be negative 2 and positive 1 there, right? Let's make sure that's right. Yes, yes, yes. And this is x squared minus 6x. So it's minus 3 plus 9. And then minus 5 is going to be that. So, okay, good. And when you complete the square here, that would give me a 16 plus 4 more. Gives me the 20. Or I'm just talking to myself. But the vertex here would be 4 to the right, 4 up. All right. So last time I had you complete the square. And again, I was trying to get you to, if you practice it, hopefully you get a little bit more fluid with it. But this is going to be x minus 5 squared, because the 10 tells me that. There's a minus 5 there, half of that, right? That means there should be a plus 25 at the end, but I have a plus 15, which means it's got to take 10 off of that to bring it back down. And that tells me this vertex is at 5, negative 10. Over here, this tells me, the 2 tells me this is a plus 1 here. But that means if I square it out, there's going to be a plus 1 at the end, but I need a plus 12. So that means there's a plus 11 here. That means my vertex is at negative 1, positive 11. Okay? And this is it to find the zeros, really. Okay? I'm going to show you in the next one. If you can get to this point, then the zeros are very easy to find. But it's finding that vertex is really the key for this. So, and you'll notice every one of these quadratics has a 1x squared out front. I'll tell you in the next one how to handle it if it's not a 1. And it's a little bit more like mentally taxing to do that, but you can still do it, and it's still good to understand the relationship between like the equation and the vertex and how everything fits together. But anyway, we're not going to worry about that right now because I don't want to get too complicated. This is going to be an x minus 2 squared because of the minus 4. That's going to put a plus 4 at the end if I square that out. And just to make sure we all understand what I'm saying when I say that, if I square that out, I'm going to get a plus 4, but I need a plus 9. That means I need to add 5 to that to get it to happen. So that's what this is. All right. Boom, boom, boom. And that tells me the vertex is at 2, 5. This is x minus 6 squared. And if I mess up, shoot me an email or drop a comment down in in the comments if you're watching my little YouTube videos. And just let me know I messed up, and then maybe I'll have to redo an entire video because I made one little math mistake. But anyway, if there's a minus 6 here, that's going to be 36, but I have plus 28, so I'm going to have to subtract 8 off of that. So this vertex is at 6 to the right, down 8. That's what that tells us. This is going to be x plus 7 squared, plus the 7 is going to give me a 49 when I square it. I need a 55, so I got to add 6 to that, right? I think so. So negative 7 comma 6. This is going to be x minus 10 squared. That's going to give me 100, but I got to get back down to 92, so that's a negative 8. So that's 10 right, 8 down. When we get to the 3's here, now we got to worry about fractions, but we can do this. That's going to be x minus 3/2 squared. And if you just know that part right there, and that doesn't scare you, that's a good spot to be in. We're not worried about fractions. If you square that out, you're going to get 9/4. Okay, so I'll write that out for you here so you can see it. I want to get 9/4 when I square it. Let's write the whole thing out. I'm going to get x squared minus 3x plus 9/4. But I don't need 9/4. I need 4, which is 16/4. So I'm going to have to add 7/4 to that to make it happen. All right, that's what I'm saying here. The number I need to add at the end of that is 7/4. So I know that my vertex is at 3/2, comma 7/4. All right. We're going to see a lot of fourths in this because, again, when you divide an odd number by 2, you get a half. You're going to square it, you're going to get a fourth. So negative 1 here becomes a half when you divide it by 2. So that means this is x minus a half squared. But if you square that, you get a fourth, but I need a 1, which means I need to add 3/4 to it. So the vertex is at 1/2 to the right, up 3/4. And when we do this one, this is going to be x minus 5/2 squared. When you square that out, you're going to get 25/4 as your constant when you do that. Okay, but I need 6, which is 24/4. So I need to subtract 1/4 off of there. So the vertex of this is at 5/2, negative 1/4. Okay, and just to show you, I'm not just making stuff up over here. Let's go back to Desmos real quick, and we'll graph this. This is x squared minus 5x plus 6. Okie dokie. And then in a different color, I'm just going to graph what I'm saying it is. X minus 5/2 squared minus 1/4. All right, you can see the red graph lays right on top of that black graph right there. They're both the same exact thing. Doesn't matter what order you put them in. They are exactly the same. There's a red one, there's a black one, there's a red one, there's a black one. Okay, let's take this minus 24 or as 1/4 away again. Let's zoom in so we can see this a little better, okay? You can see they're not the same graph, okay? But their vertexes have the same x value, 2.5, 2.5, or 5/2, okay? And that's what I'm saying. Like when I square this out, I'm going to get the 25/4, but I need 24/4 because the 6 is a little bit too small for the perfect square. This is a perfect square that's sitting right on the axis. So if I subtract 1/4, it drops right down there. And you can see if I put like a plus a right there and make a slider for a. When a is 0, there's my red graph. And as I make a smaller, all I'm doing is bringing it down so that it gets right to it, but it's going to skip over it because it's a fourth. But if I make it negative 2.5, nope, negative 0.25, there we go. It lands right where it's supposed to, and you can see they're the same thing. All right, and while we're here, let's just go ahead and play with this a little bit. X minus, you just see h. That, and I'll make sliders for those. All right, so right now, this graph is right here. Let's go ahead and plot the point h comma k, which is right there. You can see the vertex. And as I move h up, h is what's in here, the minus h, okay? As I make h bigger or smaller, so as I make it a positive, so it's minus h now, right? So when I do minus like 4, well, I'm going to run out of room here, but let's zoom out some. When I make minus, you see it moving to the right? As I make the minus h bigger, it moves to the right. As I make it smaller, it moves left. And when it becomes minus and negative, so x minus negative 0.8 is really plus, right? So when it's a plus in there, that's moving it left and right. Okay? I'm writing in this format because you usually see x minus h because h is the value of the vertex. Like if I let h be 2, the vertex is at 2. And if I change k, if I make it bigger, it moves it up. If I make it smaller, it moves it down. That's it. Okay, and next time we're going to talk about, and you can see as I pull, so let's k be 0 for a second. Here we go. If k is 0, chill. You can see this sits right on the axis, right there, right? If I zoom in, it's sitting right on the axis. But as I make k smaller, as I bring it down, what happens is it has to cross the axis twice now. And you can see the roots are here. And the further I bring this point down, the further out these zeros have to go. And that's what I really want to show you. As you pull it down further and further, the zeros from 2, which is where the vertex is for the x value, they move further and further away from 2. Okay? That's all that's happening. It's like opening up some. All right. So check me back, or check out the next video for part 3 if you want to finish this up and see how to find the zeros from all this information.